First, let's tell some introduction about pickup graph and the flow simulation, and then if we see about objective and my target achieved and to be achieved and conclusions. We start with first the evolution of pickup graph. When it came, it's actually the demand of a poor farmer working in Australia. He wanted a vehicle just to take his family to church and Sundays and his goods on the town on Monday. So he demanded a vehicle, writing a letter to the director of school, and he responded it by just designing a vehicle just to help them in a good way, and it has a big kind of more customer attraction towards it. And first they designed it in 1900s. However, what that was done by a Chevrolet, it was a resemblance of pickup truck. It's not actual pickup truck. And next was done in the Ford by 1928 is a proper pickup truck. I can show you some example of those vehicles which were designed. And to see about some flow history. In ancient civilizations, they doesn't know what's the behavior of fluid. They were very fascinating to know it. And between that, years 1536 BC to 1730, 83 AD, there was many research and contribution of many scientists towards understanding the fluid behavior. They have discovered hydrostatics and lot many theorems to know the fluid behavior. And lot of understanding and researchers, most findings were done before 20th century. The effect of fluid flow is shown here. When the vehicle moves in the opposing the fluid flow, there is some force acting, the right, drag and left. Drag which opposes the vehicle motion towards front side, and lift which opposes the gravitational force acting as the weight of the vehicle. And types of flow which is actually existing. There are three types of flows, that's turbulent, transient, and laminar. To speak with turbulent, we can denote it by Reynolds number, which is less than 4,000, and the Reynolds number between 2,030 and 4,000 is transient, and Reynolds number less than 2,000 is laminar. And the important factor which governs the flow when the vehicle moves in the opposing the fluid, it's related to our aerodynamics, the Reynolds number, drag coefficient, and pressure distribution. Let's see what's the Reynolds number, pressure distribution, and coefficient of drag. The pressure distribution, the Reynolds number is a dimensional quantity, and it helps us to quantify the inertial force actually. The Reynolds number is directly proportional to velocity, so it increases along with the velocity. Reynolds number, and the relation is shown here. It's Reynolds number is equal to rho Vd by mu. This is rho is density, V is velocity, and the distance covered by the object intersecting with the fluid, and the mu is the viscosity. And the coefficient of drag. The coefficient of drag is a dimensional quantity as well, and it is indirectly proportional to the fluid efficiency of a vehicle. The fuel efficiency. So the automotive industries, they just try to minimize their coefficient of drag as much as possible to increase the fuel efficiency. The relationship of the fuel drag coefficient is shown here, which is the drag coefficient is Tv, and the drag force is Fv, and it's half of the rho density and relative velocity square and area occupied by the object. And the pressure distribution. The pressure distribution is the intensity of the pressure which is distributed along the surface of the vehicle when it moves at a particular velocity against the fluid flow. It can be well said when the flow is turbulent and the wake is created and the compressive force occurs, and this compressive force increases as the pressure distribution as well increases. And my objectives: computational fluid dynamics, and here what I'm going to do is the objective of my project is to minimize the drag by changing the rear end of the vehicle, and whatever way we could minimize the drag, I have tried by using this SolidWorks and ANSYS to simulate the flow and model the vehicle in SolidWorks, and I have tried to maintain a speed velocity of 70 miles per hour. To help this simulation, I have carried out a simulation in SolidWorks, the ANSYS. Improvement of the vehicle behavior when related to aerodynamics is that these are the factors which is governing to improve the vehicle. This drag position, as I said earlier, drag position, turbulent flow, pressure distribution, and notch number. The three main reasons to choose this topic is the early stage there is no attention provided towards the truck aerodynamics, and wherever the flow the drag force acting on the pickup truck is more when compared to all other light vehicles. And to gain in-depth knowledge in aerodynamics, this is the pickup truck I designed in SolidWorks. It is not the dimension first, initially is the primary model, as I have shown you. Target achieved so far. I have done a literature review to know about the backup of the topic and many other technical points which I gathered during the literature review is being noted, and I have got a discussion with my project supervisor who helped me by saying what way we can go to achieve my target. And also the pickup truck is model SolidWorks and analysis in ANSYS. To start with, the procedure is being quite not easy, so I'm just learning it. This is the first primary model I have made, and this is development I have made it, and the final model I have been ready. I have yet to make the simulation. So the target to be achieved is how to make the simulation ANSYS as well for tailgate. As I said earlier, I'm just going to make the changes in rear end by making the tailgates extended and tailgates closed. So I will just compare these two results, and I will find out which is the best design, and I'll give the conclusion with the supportive of my graphs and other supportive material I am getting. These are the samples of the pressure distribution results which I will get after doing the analysis. Thank you.
Okay, thank you very much. Caught me up a little bit there. Professor Sobart, do you want to start the questions, or do you want me to?
I can lead up with a few.
Yeah, if you would like to.
So intriguing topic, because you never mentioned it